You can hear me, yes? Every once in a while, the European Forecast Center comes and visits us in order to interact with users and with researchers from AMET and from Spain all over. And this is one time. We have several times before. So I would like to introduce our two speakers for today from the European Weather Center. One is Andy Brown. He's the brand new Director of Research of the European Weather Center since July. But before he was the Director of Science in the UK Met Office, so he has a lot of experience in science and forecast and research. Afterwards, our second speaker is Anna Jelly. She's there, sitting there. She's an international liaison from European Center, and she's a training advisor and for forecast and everything, and also is specialized in a Copernicus program, which you must have heard of it. So, without furthermore, I let the word to Andy Brown.
Please. That doesn't look promising. Thank you very much. It's a pleasure to be here. I've only been at the European Centre for just under a year now, but I said to Anna I wanted to go on some of the member states' visits. So while I've been here years ago when I worked for the Met Office, it's a pleasure to come back in my new role. I'm going to run through some of what we have been doing in the last couple of years and where we're going in research. I'm sure lots of the slides have much too much detail. I'll leave the slides behind. Happy to discuss things afterwards. So, really, what are we trying to do? Our council approved the new strategy a year or two ago now. Really, I think the main issue is high impact weather. We're typically good for 1 week ahead, really trying to regularly get good forecasts for 2 weeks ahead. And then looking further ahead, 3 or 4 weeks ahead, runs of storms, heat waves, really trying to get skill on that time scale and then out to the seasonal prediction. And really pushing seamless and ensemble approach and high resolution. So we have a vision of a 5-kilometre ensemble system for 2025. And I think hopefully some of the work I'll show you'll see is sort of consistent with these directions. And as it says here, a huge part of what we, I'm very proud to work at the European Centre and how many strong scientists we have there. But we can't even nearly do the job on our own. So the collaborations we have, both on the research side and crucially in actually getting the products used and the user feedback, it's absolutely crucial to us. So challenge us today and tell us what's good and what's not good. So I'm just going to run through, as I understand, these visits happen every 3 years or so. So I'm just going to run through some of the big highlights from the last couple of years, some of what the next cycle we're going to introduce, and then the future research directions. So back in 2016, I think one of the big changes was upping the resolution of the models. So say we have a vision to be running at 5 kilometres for the deterministic system. There was an upgrade done back then which took the deterministic high-resolution system to 9-kilometre resolution and the ensemble system to an 18-kilometre resolution. I think you can see the difference this is making. This is the spectra, so how much energy the model has at different scales. So on the left-hand side of the plot, you have the big global scales, and on the right-hand side, you have the small-scale weather features. And like the black line is truth, what the real world looks like. The dark blue line, the one that says TL1279, is what the previous operational system was like, and that red line was the operational system we moved to. So it introduced a lot more detail in the small-scale features. And so if you want to get the small, low-pressure systems, the depth of the systems. That was important. Next, later that year, I mean, this is fairly typical. Don't worry, I'm not going to talk about all of this. You know, any of these model cycles have lots of different upgrades. I'm just going to focus just on a few of the key examples. One of the big ones was increasing the resolution of the ocean model. We've always had an ocean model if we're trying to do seasonal forecasts. A few years ago, we introduced an ocean model for the Ensemble medium-range system. And in fact, this year, even the high-resolution system will have an ocean. But when we first put an ocean in the system, it had 1 degree resolution. If you look at the right-hand side of that plot, that's what the ocean currents look like in that part of the world if you run with a 1 degree resolution. This is what it looks like if you run with a 12th of a degree resolution. So all sorts of ocean eddies transferring heat around in important processes. We still haven't got a big enough computer to be able to do that, but we were able to upgrade from 1 degree resolution to 1/4 of a degree, shown in the middle. So you can see it's just beginning to get some of the key ocean processes better. And at the same time, for the first time, we interactively had a sea ice model. And certainly, clearly in high latitudes and near the poles, that's important. But even down to Europe, there's evidence that in some circumstances, better predictions of sea ice for the more extended range forecasts helps. And so that's a sea ice model from Belgium that was implemented. So instead of just saying the sea ice is fixed, the model now predicts how the sea ice changes through the forecast. And I guess unsurprisingly, this is just showing that the ability to predict sea ice is better when you actually have a model of sea ice. So this is looking at errors in the forecast, and where it's blue, changing to the new system has reduced the errors. So, yeah, reassuringly, we can predict sea ice better. And there's been recent evidence showing on the sort of the week 3 and week 4 timescales, the ECMWF system is actually performing very well in comparison to other modelling systems. We continue to make a lot of efforts just to use satellite data better. There's a wealth of investment into putting satellites up there, but the techniques to use them, whether it's the details, the assimilation, the modelling of the errors. One thing that we've historically done is effectively assumed that the satellite is seeing down through the same grid column in the model, even though if the satellite's looking on a slant, it just took a single profile straight up in the model. But if you consider a satellite looking at a 60-degree angle, the ray would actually move 25 kilometers sideways in passing through the depth of the atmosphere. So in this cycle, for the first time, given that the model's now running with 9-kilometer grid squares, it made sense to worry about it seeing that cloud in the next grid box on the way down. And putting that in was shown to improve the quality of the forecasts. Getting closer up to date, so this is the last forecast cycle that we did actually implement, 43R3, back in July last year. As usual, a big mix of things that went into it. I can talk after this to anybody that are interested in any of the individual details. Just going to pick out again a few of the sort of key highlights. So the first one is that in the data assimilation process, when we bring together the previous forecast and the new observations, we have to effectively weight together how much to believe the new observations and how much to believe the previous forecast. And what we've been increasingly doing in recent years is using the Ensemble system itself to tell us how to do that. If the Ensemble is very spread, the same Ensemble that the forecasters would use, if it's giving lots of different answers, it says we're not really very confident in the forecast, so you should give even more weight to the observations. If the Ensemble from the previous forecast was very confident, then it means actually there's a lot of value in that forecast, and relatively you weight it higher. And we started using information from the Ensemble to decide how to use humidity observations, which we weren't previously doing. And this is an example looking at vector winds, just the winds errors in the tropics. So this is looking, the top left is the short-range forecasts, going down to a 5-day forecast in the bottom right, looking at the changes in the wind forecast errors, and green and blue is good. So you see, actually having better information about humidity gave us a quite dramatic improvement in the wind forecasts. It's effectively because the forecast system sees moist patches in the tropics moving in time and is sort of inferring what that means for the winds. So the humidity information improved the winds. We had quite a lot of trouble a year or two ago with some of the tropical cyclone forecasts. We've always been good on tracks, but it's been more challenging. If you looked at the structure of some of the tropical cyclones, look here, this was fairly typical. You see, the data assimilation process introduced a rather odd-looking double centre. Another example here. That's clearly not realistic. Trying to bring together the data and the background model has ended up producing a clearly unphysical structure. And lots of our users and member states, not unreasonably, said that that's just not credible. And we agreed. So there was a lot of work done in response to that. And so I won't go into the details of what was done, but again, it was some of the details of these background errors, and the way we used, quite often dropsons dropped into these tropical cyclones, and exactly how we treat those and use the data from those was modified. I think you can see, if you look on the bottom right, the left-hand panel was what we had before, one of these sort of double-centre tropical cyclones, and the right-hand panel was where we went to. So, yeah, there was a blip in the quality of our tropical cyclone forecasts, but I think that's been addressed. And certainly through the last tropical cyclone season with the series of really devastating storms in the Caribbean, I think our track forecasts were, I think, quite impressive. We continue to struggle on the intensity, but in research mode, we've been looking at if we used a 5-kilometre ensemble instead of an 18-kilometre ensemble, you can see the intensities get dramatically better, which reassures us that we're heading in the right direction. A lot of work on just trying to improve the code. I don't know if you struggle with the same issues, but these weather prediction codes are getting more and more complicated, millions of lines, hard to maintain, not necessarily running as efficiently as we would like on new computers. So this was just one example where we took the radiation scheme out of the model, effectively completely rewrote it in a more modular way, more modern coding practices, not trying to improve the science answers as a first step, but just trying to have it all coded better, more flexibly. And crucially, it's 30% faster to run. And so if we have a fixed amount of computer power, and we can make any aspects of our code deliver the same science using less computer, that leaves more left over to run more ensemble members. Or on the radiation, we currently only run the radiation scheme in the ensemble every 3 hours. One of the things we're looking to do in the future is to upgrade to do that hourly, because we believe the hourly radiation in the ensemble system will give better guidance to the forecasters for near-surface temperatures and the like. A lot of work on aerosols. I mentioned there's the Copernicus program, which does the CAMS project in Copernicus, has major sort of modelling of air quality and aerosols for their own sake. What we're doing here is trying to worry about the representation of aerosols in as much as you need it to make the weather forecast better. So what we actually did here was there's the really detailed aerosol modelling done under Copernicus, where they're looking to predict the aerosols. and taking a much better climatology from there and re-importing that climatology back into the NWP system. And we could show that gave some benefits to the weather scores, not just to aerosols. You know, in particular, the Indian monsoon simulations were improved by having a better representation of aerosols. I think it was quite a nice example of the benefits of ECMWF having and running the Copernicus cams, that we could take the outputs from that and feed it back to make the more traditional forecasts better. So what's coming next? So, I mean, Anna may touch on this as well, but the next cycle is coming in June this year. As usual, there's a sort of big list of things in it, but probably the single headline is that even the high-resolution deterministic forecast will no longer just be an atmosphere. It will be coupled to an ocean and sea ice. So that will mean that all the ECMWF forecasting systems, high-res, ensemble, monthly, seasonal, are all in exactly the same way coupled to an ocean forecast, which we think gives accuracy benefits for all of those timescales, and it makes it much more efficient for our researchers to be all using the same systems rather than everything being different for the different timescales. So, a list which you can look at your leisure. So just a few examples. This is looking at the effect in the high-resolution deterministic forecast of adding in an ocean. This is looking at temperature errors, short range at the top, down to 8 days at the bottom. And so, in coupling to the ocean, we get a better ocean initial condition, and then as the forecast progresses, the fact we actually have a coupled model gives benefits. And on this plot, blue means we're improving the temperature forecasts. And see that the main impact are definitely in the tropics. I think that's what we'd expect. On these shortish range timescales, the most direct impact of coupling to the ocean is to the tropics. If you look on slightly more extended range timescales, you start seeing the links of that to mid-latitudes. But really, quite strongly positive signal for temperature and for other measures, particularly in the tropics. And if you look at tropical cyclones, it doesn't make much difference to the track. It does improve the intensities. So, because we don't have enough resolution, we don't always get deep enough, but there can be a tendency for the model to spuriously deepen some weak storms. And what happens if you couple to an ocean is that a tropical cyclone extracts heat out of the ocean, then the ocean cools, you see a cold wake where the tropical cyclone has been, and then because the ocean has cooled, the hurricane can take less heat out of it. So some cyclones that were spuriously too deep are not spuriously too deep in this system. So overall, the intensity scores are improved. We've also introduced a new seasonal system, System 5, that went in November 2017, again using exactly the same ocean resolution, quarter of a degree horizontal resolution, 75 levels, the same sea ice model as the other timescales. And we can see, particularly in the tropics, the El Niño forecasts are much improved relative to its predecessors. In high latitudes, I think we have quite a significant improvement, largely through the sea ice. I think, if we're honest, the performance in mid-latitudes is similar to System 4. I think there's further to go in understanding the performance in the North Atlantic area. But overall, a strong improvement on its predecessor. Some of the other things in this cycle that's coming in June. I guess this is quite like, as I said, we'd recently worried about satellites seeing down in a slant through the atmosphere. Until quite recently, until this cycle, the forecast system effectively assumes that the radiosonde goes straight up. We release it in this grid point, and it goes straight up. And perhaps 10 years ago, when either the model resolution was much poorer, or just there were other bigger errors, there were bigger things to worry about, that wasn't a major concern. But if you actually look at, it probably isn't very clear, but this is individual radio songs going up, just showing where they were. And if you search hard enough for one in the right place, you can find ones which travelled hundreds of kilometres downstream. And if you imagine with our model with a 10-kilometre grid box, that's an awful lot of grid points downstream. And so from cycle 45R1, we're properly allowing for the later parts of the ascent. The data is going in a different grid point downstream. And you can see that that does, it's not dramatic, but it does improve some of the upper air performance. Changes to the physics. This is probably a very UK and Northern European problem. Yeah. Drizzly, warm sectors. we have a lot of those in Britain. But there was an issue that quite a lot of member states have reported where, in these sorts of conditions, you tended to get a lot of rain and drizzle very much on the coasts, as shown here. It's a very typical example. If you looked at the radar picture, the precipitation should have been progressing further inland than it was. And that was a very systematic effect in these sorts of conditions. And so there's a lot of really detailed work which involved collaboration with the international community, with research aircraft, detailed physics modelling, to really get into the real details of the microphysical processes, the rates at which cloud droplets combined form rain, how fast they fall, what the evaporation rates are. So the real subtleties of all these processes we had to rely on external expertise. But having taken that and upgraded the microphysical package, you can see the picture on the right, which is the same case study with a cycle that will be implemented in June. We are getting this more inland penetration. And the same changes also affect cloudiness and radiation on a global scale. So this is looking just at the shortwave radiation, so the solar radiation. So the green colours mean we've got too much reflectance, whereas the yellow colours mean we've got too little reflectance. So too much sunlight is reaching the surface of the Southern Ocean. And if you look at the seasonal forecast system, it gets much too warm there. Just unsurprisingly, there's too much radiation reaching the surface. These same changes that improved that forecasted relevant signal, that's what we get to. And in particular, the Southern Ocean cloud errors are dramatically improved. And effectively, that's from a better representation of supercooled liquid water. And then just a diagnostic thing in 45R1 is, for the first time, we've got a new product. I think Anna will show more of this, just actually diagnosing the risk of lightning out of the model. So, again, it's related to the microphysics and things we represent, but we now have enough detail in the model to be able to attempt to predict lightning. And we've been doing comparisons with various data from around Europe, and so this is observations of 6-hour mean lightning flash densities, and there's the diagnostic from the model. So, I'm sure there's certainly been a strong user demand for this product. From what we've seen in our initial verification, it looks promising. I'm sure when this is starting to get used, I'm sure the feedback from people who are really using it day to day will be really useful in making it better. But hopefully that will be a useful product for the users. I won't labour this. The overall scores of this cycle, I think for the high resolution deterministic, it's mildly positive. I wouldn't try and say it's wildly exciting. It's certainly positive in the tropics, where the ocean coupling helps a lot. Slightly positive in the extratropics. For the ensemble system, a bit more mixed. One encouraging aspect is we're trying to very much take this seamless approach where if we improve the forecast for 2 weeks ahead, hopefully the same science should improve the forecast for 4 weeks ahead, or the seasonal system. And so this is looking at what this cycle does, so looking out to a month ahead. So that's the scorecard for the monthly forecast, where the first column is week 1, the second column week 2, week 3, and week 4, with various measures. And the yellow colours are bad, and the blue colours are good. And so, again, yeah, it's incremental steps, but I think it's encouraging that we are getting a positive signal for the extended forecasts in Europe. So finally, looking further ahead, where are we going? We've got, many of you probably know, we're getting a new data centre in Bologna in a couple of years' time. So there's going to be a very, very major effort to sort of transition all our systems to Bologna, and I'm sure that will keep us very, very busy for a year or more. So effectively, we have one more cycle that we'll be able to implement next year before we have to get into the transition. So a lot of work going on at the moment, preparing science for that cycle for next year, 46R1, which I'll show some of now, and then just say a little bit of looking even further ahead where we're going. Well, that's the timeline just said. Next year. So what the big things going into it? I'll show some of the data assimilation upgrades. Probably worth just mentioning the Ensemble radiation. I think I already did say, looking to move that from 3 hours to 1 hour. That looks very positive for near-surface temperatures. Improving the wave model. But maybe just get into some of the details. So quite major changes to how we run the data assimilation. At the moment, effectively, we decide on a time, right, we want to run the forecasting system. Yeah. The forecasters want to forecast at that time on the right. We need to start running the system here. So we need to say, right, we'll use the observations we have up to now. But actually, the data assimilation is sort of iterative. It does lots of what we call outer loops to get to the solution. And each of those is just trying to do the same thing a bit better. And so there's no actual reason why you couldn't let more observations in there or more observations in there. And that effectively means that the same forecast can be using some more recent observations. And so what we're looking to go to is this system where you put in the observations all the time. So for the user or the forecaster to get the forecast available at the same time, effectively you're using much more recent observations. And because you're doing that, it also no longer actually matters how early you start. Because I can always just come backwards. So instead of having 3 goes around the data assimilation, I can have 4 goes around. And that makes it more accurate, but it won't be delaying the forecast because I can just start earlier. So yeah, so the observation cutoff time is moved. We'll also run the data assimilation more often. We'll also have slightly longer data assimilation windows. And we're obviously very early in the testing of this, but you find this is just a single picture of extra observations that are in this new configuration that wouldn't be in operation. And I'm not going to labour the detail of all the results, but all of these processes, it really looks like quite a significant upgrade to the accuracy of the forecasting system. So we're optimistic that this can sort of deliver real value to the users next year. Also looking to upgrade the Ensemble system and the Ensemble of data assimilations. At the moment, we run 50 Ensemble members for the forecasters and users, the data assimilation system only uses 25, effectively to save computer power. We're testing what would happen if we use 50 members in the data assimilation. And the scores, blue is good, or down is good on that plot on the right. That's looking very promising as well. And we've made quite a lot of efficiency savings to the coding system, so we're able to implement this. We can absorb the extra cost, so it won't affect the time available to users. Yeah. Yes, there will still be singular vectors. Yeah, we have the conversation about every 5 years of, do we not need singular vectors anymore? Can we only do it direct off the Ensemble data assimilation? I think it will still be a hybrid of the two. The weighting or the tuning may need to change, but yeah, the singular vectors don't disappear that quickly. And then continued changes to the details of the radiation, the convection, and the microphysics. I won't labour the details. These are the sorts of things you don't really notice if the sorts of scores you look at are Z500 and mean sea level pressure. But if you look at the things that arguably are more important to the users, like near surface temperature and low cloud cover, so that's 2 meter temperature on the top row, low cloud cover on the bottom row, and down is good, below 0 is good. And so I think these changes looking promising for some of these more near surface weather metrics. So in all of this, this is very early testing. I'm not sort of promising this is exactly what the cycle will look like, but we're very keen, particularly with the transition to Bologna coming, to get in a really strong cycle before we go there. And I think it's quite a promising set of things there. So finally, just a few slides, and that's a year ahead. But what about when we get to Bologna? What are we actually going to do when we get there? Now, we were delighted our council approved a significant extra investment in supercomputing for Bologna. So obviously one of the things we're working on very hard is making sure we have plans for how best to use it when we get there. So I've already touched on this, but just scalability and the efficiency of our codes is a huge aspect for us. So we're really looking at all aspects of the code, from how we handle all the observations when they come in, the data assimilation algorithms, the heart of the numerical methods, the model itself, and then when the models produce all this gigabytes of data, how you process it, how we make that run efficiently on today's computers, and even more, how we make it flexible enough to be efficient on computers of the future that we don't even know what they're looking like. And one example that we've been working very actively on is just the precision that we run the forecast model at. At the moment, it all runs in what's called double precision. So this is looking at how many forecasted days we could run in a day. If we just sort of set the computer running for 24 hours, how many days of forecast could it do? And our current 9-kilometre one, if we run on 120 nodes, we could do 170 days of forecasts in a day. If I use more nodes, 240 nodes, I could do 323 days in a day. But it'd be lovely if we could do more. If we could do, and this is what happens if instead of running at double precision, I run the same simulation in single precision. So it's doing all the calculations just slightly less accurately. And now instead of 170 days in a day, I do 295. So I've got a 40% speed up from running in single precision. So that's great. Obviously, the key question is, does it matter for the results? This is just a single case study. I'm not pretending this is a proper validation. But here's near-surface temperatures over Italy, the Balkans. There's a single precision forecast. There's a double precision forecast. And I would challenge anybody to find the difference. And so, obviously, we're doing much more serious verification across lots of cases, or are there particular meteorological conditions or quirky things where things can go wrong? So we're chasing this down. But I think we're very optimistic that we will be able to do this. And if you spend £20 million or 20 million euros a year on supercomputers, and you make your code 40% faster, you can argue that's about the equivalent to £8 million you've just saved yourself, or £8 million to invest more usefully. So, important stuff. Yeah. We're thinking. No, we're thinking to run all the model in single precision. At the moment, we're still planning to run the data assimilation in double. So both the model, but actually probably more importantly, the forecast, because for the extended, for the Ensemble system, the extended range forecast and the seasonal forecast, running all the reforecasts is a very expensive part of the system. So we've not seen. There's a slight issue when you do the numerics in double precision. In single precision, you very slightly lose mass, but a very simple mass fixer seems to address that without affecting the meteorology. So, I mean, we're continuing to look and check, but the plan is, model all single, data assimilation all double, research project at the University of Oxford looking at, some people say it's just inherently impossible to do data assimilation in single precision. That might be right, but if it's not right, it would be good to know. So research into that side. Doing a lot of work, just experimenting, however big a computer we have, just what's going to be the best way to use a computer in Bologna. So this is just investigating research mode, different combinations of, for the same cost, I could run 200 ensemble members at 29 kilometers, or 50 ensemble members at 18 kilometers. Which is better in terms of forecast scores, and similarly at higher resolutions. And the headline results we're finding, which maybe is intuitively what you'd expect, is that for the shorter range parts of the forecast, perhaps the first week, resolution tends to be more important than number of ensemble members. If all you cared about was week 1, you might go for the smaller ensemble at higher resolution. If you're looking out at week 2 and 3, the equation tends to turn round, and a larger, poorer resolution ensemble does better. Now, the details of this depend a bit what metric you're looking at. Of course, if you're looking at orographic precipitation, you need the resolution. But I'm really just showing this as illustrative of the sort of work we're doing, exploring the parameter space in order to inform what would be the best way to set up our systems in Bologna. And I think this is probably my last slide. Looking even further ahead, we're very confident that the IFS is a very efficient code. We're working hard on the scalability, but in an absolute sense, it runs well, and we think it will run well for the life of the next computer. If you start looking to later in the 2020s, evolving computer architectures, GPUs, more heterogeneous computers, will the IFS, with its spectral transforms and global solvers, run well? Possibly not. So we're working in collaboration with major European partners and consortia, looking at some of the building blocks of these NWP models, testing new dynamical cores, more local ways of doing it. We've got a major bid into the Commission for one of their flagships, or preparatory action for a flagship called Extreme Earth, looking at the whole way we do NWP. So, this isn't operationally relevant in the short term, but it's work we need to be doing now to be sure that we're still doing what our users need in the mid and late 2020s. I think, that's that. Thank you.
So, thank you for a very interesting presentation. I think I open the floor for questions for Andy. anyone that wants to ask a question, please.
One question related to, I see that you have data simulation. There is a long-standing issue, which is that the surface data simulation and the upper area data simulation is part.
Yeah.
Have you heard about ways to go from this? Because obviously it's not.
Yeah. Well, I think that probably answering your question in the broader sense. We're very actively looking at sort of coupled data assimilation in the broader sense. So this is probably answering more from the ocean perspective than the land assimilation part. But oh, sorry. Yeah. Sorry. Yeah. So we've been doing work on coupled data assimilation, looking, for example, in the outer loops of the data assimilation using the coupled model. So it's not truly coupled in as much as an observation in one system really directly having the covariance onto the other system, but it's coupled through the outer loop. And so the Cirrus-SAT that we did took that approach and the vision actually is that the next reanalysis, the ERA 6 reanalysis we'll be looking to do in the 2020s, will be doing that. So I don't think we have all the answers. It will be incremental steps, but we're looking to move in the direction you imply, where you start getting more consistency rather than this completely separate and then bring together.
That's already more or less implemented now. For the bar
Yeah. Yeah.
Yes, we have the AMF delegations watching us, and maybe they want to ask questions. I open the floor for them. Are you ready for questioning? Anyone? Okay, we have a question from the floor. Yeah.
Yes? Almost complete. So parts of it are, I should know the exact answers, but I think the last 10 years or so is already available. The other streams are complete or almost complete. So it's just in the coming months. I don't know, do you know more detail the actual dates, Anna? I could certainly find out, but yeah, very, very nearly done. And I think we've actually been testing some of our systems because we use ERA interim ourselves a lot for, either for verification or for initializing, if we're initializing the seasonal forecast. And so we ourselves will need to be switching to use ERA 5 rather than ERA interim, because the plan is that ERA interim will not transition to Bologna. So so users, including ourselves, need to be transitioning to ERA 5, and to say that the scores so far look promising. We can see when we do the reforecasts initializing with ERA 5 instead of ERA interim, the scores look better, with maybe the only caveat being in the stratosphere. Okay. Yeah.
Okay.
I'm around all day, so I'm certainly happy to have more detailed conversations with you.
Thank you very much, Andy. So let me introduce the next speaker from the European Center, Anna Jelly, International Liaison Coordinator for Training Activities and Copernicus Program. Thank you, Anna. I would think so, yes, maybe it is. Hi? Yes, I think so.
So, good morning, everybody here, and the people in, maybe I can sit, and maybe people in remote. My part of the talk will be about a selection of topics, so I hope there will be something for everybody. So I will look at computing aspect, product, performance of model, etc., etc. I always like to start, how do you progress this? I always like to start my presentation by reminding everybody of our current forecasting system, which includes obviously the Ensemble as one of the models that we run, and the seasonal forecast and the monthly forecast. So here is the outline. So you are aware that we are running on the high resolution model at 9 kilometers, 137 levels up to day 10. Then we have an ensemble forecasting system which goes all the way to day 15. So this is actually a change. I don't know if you remember, we have up to day 10 and then we had the transition in resolution. So now we're running until day 15 at 18 kilometers, and after that, twice a week we run a monthly forecast, so extended range forecast, as we like to call it, at 36 kilometers. So you will nicely see that we are moving towards more of a seamless system, and this is also what Andy was mentioning before, because if you look at our extended range and you look at the seasonal forecast, you will realize immediately that the resolution of the models is very similar, even though at the moment the cycles are not the same, but we are moving in a direction of self-standing sort of wave model, which I believe some of our member states are actually using for their own purposes. The next slide is just giving you a little bit of a flavor of what Andy was mentioning. So it's a timeline with all the various cycle changes. And I think I'm highlighting from 2016 because last time we came to visit, it was in 2015, if I remember well. So this would be all the changes that we had in the past 3 years. Andy has mentioned all the various changes in terms of the model, the research side, and here you can see I've also added to the various model all the new parameters that we actually introduce. So every time we change model, we tend to take the opportunity to add some extra products for forecasting purposes mainly. Some of these products I will show in a minute because these are all part of products that you may not have seen, even though you're probably already using them. I hope you actually do. Before we go to the product, though, I would like to show you a little bit about the verification because I think you may be interested in knowing how well we are doing since some of the money that we get is actually coming from Spain. So we usually present a set of scores. This is something that was agreed in one of the TAC, the Technical Advisory Committee. So we had a set of scores to show to our member states. So recently we have added a couple, and you will see them appearing in the supplementary score. And this is a percentage of large temperature errors, which it's a very nice diagnosis because it tells us a little bit how we are improving in terms of decreasing or increasing, hopefully decreasing, the number of large errors in the years. And one extra one is very specific for the extended range, and it's about anomalies, so looking at the terciles, so the extremes of the forecast range, of the probability distribution function. And this is very interesting because it's very much like user-oriented verification. In this specific one, we are looking at the terciles in temperature, so they will give you some information about cold and how we are doing in terms of cold spell and warm spells. And you will see an example in a minute when I go through the scores. So the first one is the standard one, which is the Z500. We like to show this, and most of the scores I will show, they will be on Northern Hemisphere or extratropics, but we have all sorts of areas. It's just I can't show them all basically. But if you're interested in a very specific area we can discuss later, and I can try to dig it out for you. So this is a little bit addressing what Andy was saying just at the question about ERA 5. So you will see on this nice plot that we don't plot ERA interim, but we also plot ERA 5. So ERA interim is the dotted black line, and ERA 5 is the black line. So you see already how much better ERA 5 is compared to ERA interim. Very, very much better. And the other thing is that we use ERA 5 now as a reference system. So we would like our forecasting system to be better than ERA 5. Obviously, before 2011, ERA 5 is better than the current the model at that time, because obviously it's a more recent cycle. But if you just look at the latest forecast, you can see that actually the current forecasting system is beating ERA 5, which is very nice. You will see there are a couple of spots where the scores are particularly good. One is around 2010, and one is around in the recent 2017 last year. So these are linked to spells of very predictable weather in the atmosphere. This was very strong NAO signals. So any model that, even if it's not very good, it will score very well. Yeah. So in general, you see that ECMWF here is plotted versus ERA interim, but also versus other models available in European models, but also models from the USA. And it's nice to see that actually at the moment our ECMWF model, I mean yours as well, ECMWF model is actually standing way up above anybody else. We also like to show something on for the Ensemble. So this is a specific metrics for the Ensemble forecasting system. So it's the continuous ranked probability skill score, so you want to have it high. And the reference system here is the climatology. And here you see different colors will give you some information about different systems. So as you progress in time, so the bottom, the x-axis is the forecast day. As you progress in the forecast day, obviously the continuous rank probability score decreases as we expect. The comparison here is between ECMWF for this specific period, which is the latest DJF, and the previous DJF from last year. So it's the same color line but dotted. You can see that it's compared to last year. This year the model was performing better. Some of it is maybe due to the fact that the atmosphere was more predictable as well. And again, here you see different forecasting system from other centers like ours. Then if we just go towards the surface, everybody likes this, and we are just showing now the performance in terms of precipitation, because that's obviously what we feel more. And again here, we like to plot ERA 5 versus the Ensemble system as it is now, and ERA interim. So you can see the massive difference between ERA interim and ERA 5, which is very nice. But also you can see that in recent time the Ensemble is actually performing better than ERA 5. So that's a nice result. And now we are just moving to extended range, and I would say that we are now scoring terciles. This is what we have here is the relative operating characteristics score. So again, it's the higher the better versus the lead time. Highlighted is the week 2. And the comparison are between the period 2015-2017 and the period 2007-2009. So this is just because we have the systems were completely sort of reasonably different. So we want to see how we improved compared to that period. And you can see in both situations, both for the cold anomaly, which is on your left, and the warm anomaly, which is on your right, you can see that the system, as it is now, is actually performing better than what we had in previous years. So quite a lot is due to the fact that we had this resolution increase, and we have a better reforecast, etc., etc. Again, you know that the ROC score is, you would like to be sort of above 0.5 or 0.5. So we are not quite there with in terms of scores being above that value, but we are progressing towards it. And I believe now with the new system, 45 are 1, we are expecting also some improvement in that direction. The last but one score that I want to show you is the Extreme Forecast Index. This is a very popular product. I believe your forecasters are probably using it. It's very, very well used throughout all the Met services in Europe, and also any company that has access to our data they are also using it very, very much, because they find it very useful to highlight situation where the weather may be particularly harsh, particularly severe. So we have here is again in terms of rock skill. So the higher the better. And for each panel you have, it's a different parameter, so 2 meter temperature, 10 meter wind speed and precipitation. And for each panel you have different lead times. So you can isolate, you see there are 2 types of curves for each panel. So you have curves are very sort of wiggly. This is the monthly values, and then you have some kind of trend on it, just to see how we are progressing in time. And you can see that the EFI has been either sort of more or less stable in terms of, for instance, the wind speed, but it's also improved if you look at the precipitation and the 2 meter temperature in recent years. Again, here is scored versus the 95 percentile of the observed. So for each point in I think this is Europe, we have a distribution of observations, and we choose the 98th percentile to score the EFI. So we score the EFI versus something that is severe. Yeah. And the last score is the one that is not new to from probably this year or last year, late last year, and this is the frequency of the large 2 meter temperature errors for the ensembles, and this is the continuous rank probability score must be more than 5K. So this is how we define the large errors. And you can see that in the recent year, they've nicely decreased from 8.8% to 7.4%. So we have decreased the number of large errors in 2 meter temperature. This is, again, for the extratropics, so it's not specific for each country. It will be looking at the extratropics as a whole. And now I'd like to show you a case study. But this is just one single slide, and I guess you did not suffer so much, but we did back in February, March, when we thought the spring was coming, and we had this terribly cold weather. And it was actually quite interesting to look at our forecast and the extended range, and this is looking at the EFI for the extended range. This is a novelty which is not available, I believe, to anybody, but we can look at it in-house. And it was nice to see that week 2, so 2 weeks in advance, we already had very, very strong signals in the EFI that it would turn to be quite cold compared to climate. This is the panel, the bottom panel on your left. Yeah, so it plots shaded is the EFI, and it goes from green to purple. Purple is about, I think something is happening. It's not working. Purple is -1. The microphone does not work. It's green. Did I hit it? Oh, it is working. Okay, sorry. I didn't hear myself anymore. Okay, so the magenta color or the pinkish color is actually -1, so that means the EFI is giving a very, very strong signal to have a potentially severe event in terms of a cold anomaly. Okay, now I'm going to go through the products. Some of the products, I believe you are already using it, and it would be nice if you could just sort of wave at me saying that, yes, you are using it and you think it's very useful. The first one is the Cape Shear. That was something that we introduced a few years ago. And this is to look at the deep convection, and it was specifically designed to look at the Cape and the shear at the same time. So just usually we tend to have parameters that are just one single element, but here we joined the two elements of Cape on instability and wind shear. And this parameter has been used quite heavily in convective situation, and so far we've heard that the result, the forecasters seem to be happy with it. But if you have different opinion, please let me know, because we can always go back and revise the way we define it. The next one is a set of products that were introduced, I think, last year, and they are specifically for aviation forecasters, at least some of them. And they are the convective cloud top and the cloud-based ceiling and cloud-based height. These were actually specifically requested by some of our member states. So we when we worked on the new convection scheme, Peter Bechtold, who is our convection guru, so to decide that maybe it was a good time to introduce these parameters and make them available to our member states. Another product that you may have started seeing for those of you who use EC charts is the precipitation type probability. We had the precipitation type had been out for quite a while. So this is a new product that you can actually plot easily from EC charts, and looks at the once you know that it's likely to be raining, you can look at the probability of each precipitation type. So there is a version which is a meteogram-like style, and is similar to what you see now on the panel here. But we also have a map style. So there is a very nice newsletter article, and it's at the bottom. The link is at the bottom of this slide, and which describe exactly how the products, the two types of maps are designed. And in a sense, there is a case study, so how it was used in a specific severe event, case of severe freezing rain, I believe, in Italy. The next one is the lightning. So this is actually not out yet. It will be out with 4501. This is a slide that complements what Andy has just shown. And you see the top two panels are the one that Andy shown. So on one side you have the ensemble mean, and the other side you have the observed flash density. But what is more interesting is to use it in a probability sense. So at the bottom two panels, you actually have the probability of having this specific one is one flash per 100 kilometers per hour. Yes, and this is for this threshold is then compared to the observations. Yeah, so you want obviously where you are observing lots of flashes, then you will want to see the probability very high. So this is a very nice way of using this product. So it's not just a deterministic product, but it's an ensemble product. And so we would love to have some feedback, especially on the ensemble part, of the way you use it in a probability sense. And now I have this very high-tech stuff. Let's see if it works. Since it does some. Oh no, not that one. That one. Ah, yes. So this is a little animation. On the left, you have your observed lightning, and on the right, you have the panel, the model forecast for the event. So obviously there will be no one-to-one match, but it's quite nice to see that the general features are there and the timing is more or less correct. Again, for this specific product, we have a couple of newsletter articles, and I would sort of encourage you to read them, because it's explained exactly how the parameterization is done, and the fact that, for instance, the lightning, you can have lightning in between clouds, but also between clouds and ground. So at the moment, in the model, we cannot distinguish between the two. So it's one lightning, whether it happens in the cloud or in the ground. It's just one number, yeah? So, and also this has got some implication with the way you verify it. So if you are so interested in the product, I suggest you have a look at the newsletter article because it's very informative. I also have with me a technical memorandum specifically on the lightning that Philip Lopez wrote. So if anybody's interested, I can give you this one copy. Now we're going to Wave. And so this is something that was introduced, I think, again, a year ago or so. And we all of a sudden realized that it may be interesting to have some extra wave parameters because people are very interested in seeing the impact on the coastlines. And so far, the parameters we had in the wave were not appropriate for this. So we introduced the magnitude and direction of the wave energy flux. And we also introduced the significant wave height of all waves in six different period ranges. As again, this one is very interesting for describing low-frequency wave energy, which I understand is quite hazardous if you are on a boat. Everything that comes out new is usually plotted available on EC charts. So if you are a EC chart user, you will have seen that we have the cloud ceiling, we have introduced the precipitation types of probabilities, but also we have introduced the model climate, so you can actually plot percentile of the model climate now, and you can calculate 2-meter temperature computed over selected user period. So there's a bit more flexibility in the way you compute ensemble means. There is flexibility in trying to see what the climate for a certain percentile is like. So there's a lot of things, a lot of new stuff in introducing EC charts. Okay. So far, we have looked at the performance of the model, we have looked at the product, and now I'm going to go and say a few things about computing. This is to please Raul. Next week at ECMWF, we have the security representative meeting and the computing representative meeting, so there will be a lot more of this information and details there. So, first of all, you know that ECMWF runs the supercomputer. Supercomputer is something that you can use. So there are two different ways of using it. One is having a special project, and the specific one is summarizing. You look at the word cloud, the breadth of topics that usually are associated with our special projects. We have quite a number of special projects, and in the table here is summarized the amount of computing units that are used by our member states. There is all the information about applying for special project is on the website, and I believe maybe Raul can coordinate it from your side if you're interested. The other way of using the computing is actually running time-critical application, which as a member state you qualify for. And here there is, again, a breadth of activity that are currently run as a time-critical application. These are the type 3, so the one that actually our operators look after this specific. If something goes wrong, they will be first-line support. And then then you are called in if we can't resolve it ourselves. And you can see there are different countries, Ireland, Portugal, Italy, Germany, Ireland. Ireland is actually, Spain is also part of Ireland. And then you have Harmony, a limited error model, which has been running since 2015 there. And then you can see that we have Serbia, United Kingdom, Greece. Greece is in discussion now to start running the Cosmo model on our supercomputer. So this is a very nice way of using your allocation, basically, for at ECMWF. So far, computing now, we do a lot of work on software development. Software development for us is packages that we need in-house. So we would not sort of usually write a package just for the sake of writing a package, but it's something that we need in-house. So the plot here shows the complexity of the packages, but they are all linked to the fact that we need to get the observation ready in by the model, the data simulation running, the model running. We need to deliver your product. We need to be able to visualize. So all the software that goes in that process is actually something that we take care of. This year we've been quite busy on a number of topics, and I've highlighted a few of them. But I'm just going to show something about PGen, the generation software. So one big thing is the interpolation package. So this was work so much due because we were running on very old libraries, EMOSLib, which some of you may be aware of. And I have to say a few things about that one. So we needed to remove EMOSLib from our forecasting system. So we've been working very hard to have a library that actually does the interpolation for the model. Grid point to model to grid point, different spectral resolution, etc., etc. The one that is it should be very transparent to you, and next week is going to be described in more detail for the computing representative, is the generation of the product. So again, this was a very old software, and we are in the process of rewriting it to make it more suitable for big data that we are going to have to deal with, and also from the fact that some of the old libraries, we will not be able to use them anymore when we are in Bologna. Some of this work is really very much geared to the fact that we are going to have a supercomputer somewhere else, and all our computing somewhere else, and we don't want to move stuff that are very old. We want to have sort of state-of-the-art sort of software. So this is so far in terms of computing a software, and now just a few words about the outreach activities. So this is one of the outreach activities that we do. So last year we finished the cycle for which covered 2014 to 2017. So this is now the new cycle of our visits. We had a little survey among the people involved in the member state visits, try to see how we can improve them to make better value for you, because we believe that coming to see you is actually, you can talk to us. It's quite nice and very useful at times. Then obviously we have the annual meeting. I believe some of you are coming to the user meeting this year. It's become really popular. We have more than 100 participants already registered, so it's going to be a really cool event, and it's all about innovation. So if you haven't registered and you really want to come, maybe you should do it soon to avoid disappointment. So this year is, as I said, is all about innovation. So we'll have some laboratory, some workshops, etc. We're going to look at virtual reality, augmented reality, etc. All done using ECMWF data, as well as other data, obviously. One other effort that we've been working on this in the last couple of years has been trying to make our learning material, training material, a bit more widely available. So we had this e-learning project, and now we have quite a number of modules online on basic topics, which are free to use, and they can be used in any of training program that you may run here at AMET. Again, some of the modules are very much NWP, so numerical weather prediction. Some of the modules are about products, so we have a specific module on the EFI, and some of the modules are on computing. So I believe next week again, Rahul, you will see there's a collection of modules that we have put together for using easy codes, the coding buffer, etc., etc. So I think this is, we would like again some feedback on this, because we believe this is actually a very good way to give you a chance of of learning, some of the things that we give out, without having all the cost of coming to Reading just to attend the course. This does not mean that we are going to stop the courses at ECMWF, but it means that we will be able to deliver courses at ECMWF at a higher level. So we will do the basic as a e-learning, online study, and then as the people come at ECMWF, they will benefit from higher level learning and more interactive learning as well. Now, one word about, we talk about Bologna, so I just wonder whether anybody is aware that our data center is going to move to Bologna. This was the winning of the bids for our data center. And it's ongoing, so the ITT for the building site, etc., I believe is coming out soon. So, and the timeline is as follows. That's kind of agreed timeline. There may be still some sort of adjustments, but in principle, by October 2020, our supercomputing facility will be operational in Bologna. So this is a quite interesting time for us. It's a lot of work because we need as I mentioned, all our software, all our generation NWP chain to be able to move to run that one in Bologna. So there are lots of details. The archive will be there. So how we're going to archive in the transition period, are we going to archive at ECMWF, and how we're going to move the tapes? Are they going to go by boats, by aeroplane, and what if the boat sinks? And all sorts of details that don't seem to be, but it's all been discussed, and it's quite complicated actually. And because of this, so because of Bologna, I need to show you the slides. Again, this is something that will be shown to the computing representative next week. This is very important because you will see that some of the software will not be available in Bologna. So in Bologna, there will also be EasyGate. So if you're running something on EasyGate, we would like you to have a look at this slide and make sure that you have moved away from the software which will not be available in Bologna. Yeah? So you will see that Grib API, EMOSLib, GribX, MatView Free, and SMS will not be available. So please, please, please move away from this software as soon as possible. We have replacement for all of them, EasyCodes. We have MatView 4 and 5. We have EasyFlow. So they are all available. They're all working. You should really try to make an effort to move away from the software and the packages that are not going to be available in Bologna, because otherwise you're going to really struggle. Yeah. So again, this one is something that will be shown next week at the computing representative meeting. So they will be then, I guess, displayed and relayed to you at a later stage. And one last slide that I would like to show is the Copernicus. So Andy has described a little bit about the Copernicus atmospheric monitoring services, but we run another service which is the climate change service, and the big thing about this one is the climate data store. Climate data store is like I don't know if you're using Amazon or something, that you will be able to get data from the climate data store, and there are different levels of getting this data. You will be just, for people who just want to get the data, for the developers there will be a space where you can actually do some manipulation of those data, and you can create your own sort of statistics, your own sort of figure plots, etc. All this is will be definitely available from June. And this is because we are going to run an hackathon at the beginning of June, which is all about the climate data. Incidentally, here we have some information about Year 5. This is for Angeles. So I think it's scheduled. It's very. The completion is, I think, at the end. I think it's at the summer or the end of this year, the completion, and then we will extend it back to 1950 from 2019. So it will be a very long data set, a lot longer than ERA interim. And there's already start discussion about ERA 6, which will be the next reanalysis. I don't think we have timeline for it yet. It's just in planning phases. And then the EuroSIP and seasonal forecasts will be transitioning. They're all transitioning to the Copernicus data store, so they will be available from Copernicus rather than ECMWF. This is the novelty. So we, in a couple of months, we're also going to start to have a training initiative for the Copernicus services. So there will be training event going around the Copernicus countries, and I believe there will be one specific of Spain. So you may be involved in some of the activity around those training events. I think that was my last slide. I hope I managed to please everybody. So lots of different topics, but the scores are very good. And
going to start a general discussion, and it's especially useful if external users, so people coming from EMET, participate and have feedback to the European Centre, or they show their problems or their requests. And maybe it could be even useful if you can introduce yourselves a little bit to have an idea of who we are. It's fine?
Hello? Yes? Yes, it runs. Well, hello to all. My name is Salvador Calabria and come from Siemens Gamesa, renewable energy. And I work at the group of meteorology at the company. And, well, that is my field.
I'm her colleague. We work together at Siemens Gamesa. And we use your data for our basic model. We forecast for all wind farms Siemens Gamesa operates and maintains, and for all planification of for repairing the wind turbines. We use your forecast to open the temporal windows. Those things can be done.
I am Daniel Cabezón from EDP Renewables. So similar to my colleagues, we come from the renewable energy sector. We work for the Energy Assessment Department, and we are also users, big users from a long time ago from the ECMWF products. Reanalysis data, especially for long-term analysis, and also for the real-time forecast for in order to decrease as much as possible the deviation cost, which is one of our most painful operations.
I am Luis Garcia from Meteorológica. We provide mainly forecast services, mainly about renewable energy, and we've been using ECMWF forecasts since many, many years ago. I think that we may be the first commercial company in Spain using them, or one of the first. And so it's a very long relationship. We also usually attend every year the users meeting at Reading. We'll be there also this year. So I'm pleased that we have this other opportunity to have contact with people from the ECMWF. I don't know if this is going to be a regular thing every year. Okay. So, but this meeting is going to be open to users, to external users? Okay, I understand. To the national center to decide. Okay. Mm-hmm. Okay. Thank you so much.
Hi, I'm Carlos Prado. I come from Meteogrid, and I am a researcher. And we use the data for projects related to climate change and improving weather predictions through downscaling. And well, we have some issues with the data, so it's useful to be here.
Hi, my name is Miguel Ángel, and my colleagues Juan Antonio, Nacho, and Carlos, we came from Confederación Hidrográfica del Guadalquivir, Ebro y Miño-Sil. It's a governmental office. Those are 3 governmental offices from the Ministry of Agriculture, and we are in charge of the management of the River Guadalquivir, Ebro, and Miño-Sil. We use the data you provide through IMET in different ways and with different levels of maturity. Mainly, corregidme si me equivoco, mainly we use them, we provide them to models to predict the flow of the rivers, to manage floods and something like that. And we also use the weather forecast to schedule the management works at the dams and so on. And may I ask a question? I would like to know if just for the plain visualization of the weather forecast, for instance, are you planning to develop or publish the geographical information with standards like the ones from Inspire and so on? Because most of us are repeating the same works or paying for the same works to process your data and publish it through geographical information system, for instance, using OGC standards. Thank you.
Hello. Well, your answer the question.
So we actually just concluded a project on OGC standards, and we're going to have actually a module, a learning module. I think the plan for us is not to do anything for the atmospheric product, but we have EFAS, the European Flood Awareness System. I think they are planning to have JS standard sort of data. So for the water management, probably this is a good chance for you to use.
I think it is an important question. In my opinion, IMET should provide this mixture of NWP output and physiographical data, because in the future it will be important to have these products more oriented to impact. So, in my opinion, the official weather service should be the ideal organism to deliver this kind of products to and we plan to do it if I'm not wrong.
Yes, indeed, we are working on that. And especially for you, I think you are a good candidate to use this data.
Hello, my name is Juan Antonio Navarro. I come also from the Guadalquivir Basin River. We presently don't have a forecast model for forecasting flows or quality matters, but we are very interested as well in quality phenomenon that can be triggered with changing meteorological conditions, like eutrophication blooms or something like that. That is very interesting, the Ensemble prediction forecast, probability of changes week to week in temperatures and that kind of products.
So, more general questions or?
Hello, I am Isabel Paradinas from Iberdrola Renewables, and we use the European Center model and data for weather predictions. And well, I appreciate very much all the products and improvements in your models, but I just a reflection is another global models the refreshing time of the outputs and the time to provide these outputs is lower. So for refreshing times and the shorter time to provide predictions. 4 times a day. 4 runs a day, yes. And well, I'm sure there's a reason to, but well, I just thank you. No.
Yeah, so you're right that our sort of core offering is the twice a day. There is actually a proposal that will be discussed at our council this summer, because we do some runs at 6Z and 18Z available, not for commercial use at the moment. And there's a debate to be had. It's been going through our committees, and it will go through our council this summer as to whether the use and availability of that data is expanded. So obviously, I can't prejudge what our external counsel will say, but that issue is being very actively discussed at the moment.
For the people in IMET, the discussion is on the BC product. You're part of the BC project. Yeah.
Indeed, we are using them, but we always have the doubt whether we can distribute those or not. Yeah. Okay. So we are very actively using it, yeah.
I have a question which is maybe related to the previous one, which is about the time resolution of the products. We know already, because we've been posing this question several times, that it's not a technical or scientific issue, but a political one. But this is not going to prevent us to pose it again, to insist. I'm sorry about that. This thing of having hourly resolution forecast, because there are other models that are available with hourly resolution. And this, for maybe the first or second day of range, these models are, only because of the resolution, maybe are they going to be more useful than the ECMWF forecasts. So maybe EC is lagging behind in this respect, and it's a pity, because you have the best model. We know that. So we would like to have these hourly resolution forecasts, that we know that they exist, but you cannot publish them because of some political issues.
Well, actually, it's really exactly the same answer as that one. The proposal that will go to our council this summer is both concerns the availability of the 6 and 18Z runs, but also hourly rather than 3 hourly data out of the main runs. So your issue may be resolved in the summer. but I'm not the council.
Hello, I've got a comment and a question, not only for you, but also for the users. You have done a lot of efforts with ensembles, and you have in some way promoted the usage of probabilistic forecast. But I've got the impression that many users are still stick to the deterministic products. And I would like to know, just to have an overview of if you have some figures of the usage of the probabilistic products, and at what extent the users are making use of probabilistic or deterministic products.
I think that's a very interesting question, because I was asking Javier earlier, actually just trying to get a sense of, he met what is it? Because you're right that we have been increasingly going down the ensemble route, and our strategy to 2025 really puts even more focus on the ensembles. So, if you like, from the scientific driver, we absolutely think going further and further down the ensemble route is the way we want to go. Having said that, in the limit if nobody's using it, that would clearly not be a good strategy. So I think we'd be genuinely interested in continuing to increase our understanding of how much is it being used, and if it's not being used, what is the barrier to it? Is it data volumes and availability? Is it training? Is it just too complicated? Yeah. So, do you have any comment? Yeah.
So definitely one of the big barriers that we have is the training, and this is what we've been trying to address, to have lots of things on ensemble forecasting, etc. But I think the perception that people don't use ensemble is actually a bit not exactly correct, because some of our products, like the EFI, you are unconsciously using the ensemble, because we couldn't have an EFI without having an ensemble behind it. For instance, if people using EFAS, we couldn't have EFAS if we didn't have the ensemble behind. And when you look at the extended range forecast, we're looking at anomalies, probability of being above or below tercile. We couldn't have this, and the people could not use those products if we didn't have an ensemble behind it. So it is true that maybe people are not downloading masses of ensemble members for their application, but indeed I think they're using a lot of products that actually unconsciously they rely on the fact that the ensemble is behind. But as you say, I think we need to do a lot more work, because by 2025 we'd only have ensembles. So it's difficult, because going from somebody who's used to have just one forecast, yes or no, then you have to shift to, okay, I have many forecasts, I have to handle probability. So people have to understand the concept of probability. People have to work on doing some processing of data to have some products that make sense and they are user-friendly, but using the ensemble behind. So I think people are using ensembles. They're just not using the members as such. They're using products that are based on ensembles. But we could do with some increase of use of ensembles. And now back to all the commercial users to find out what they're using.
Thanks, Anna. Daniel from AMET and also from Hirlam. It's not just to follow in the discussion about EPS. Also from Hirlam, now you know that there are some countries like Medcube that only produce EPS as output from limited area models in 2.5 resolution. So the same road, the same mainstream is also from the short-range forecast. So it's important also for us, for AIMET, and also from Hirlam to know how these users, external users, are you going to use in the short range and also in the medium range all this EPS information. So we are thinking how to promote the use of EPS also for the short range, because in the future it's not going to be only a single model anymore.
One of the most problems, the biggest problems that we have currently is the ice on blades or the wind turbines. The ice accretion on the blade surface, so that causes lots of problems. So it is something that I asked before to Andy, but I would also like to know your vision in terms of how commercial, if there's something available in an ERA 5 dataset. We are looking for some variable that can tell us how severe was a particular winter of a particular year compared to the long term, or how severe has been a month or a winter, like a companion of several variables. Does it exist in the ERA 5 dataset? Mm-hmm. Because we found very interesting that extreme forecast index, but I guess that is just for forecast, not for hindcast. Mm-hmm.
So it wouldn't be possible to do for ERA 5 because we don't have forecast.
Yeah.
But indeed, this ERA 5 for the forecast, for the assembly, is actually based on
Okay.
So as far as ERA 5 is concerned, I don't think we have any product like that. But, what? When we have the information, you're welcome to use it after the product.
Mm-hmm.
And then you can just keep it up.
Okay.
Because it would be possible, if you are an expert, it would be possible to code something.
Okay. To make some combination of variables. Okay.
What you're asking is not impossible.
Yeah.
It's a concept, but
Okay.
just for
No, just to save time, and we're just if there's something available. So, and if I have another question, another topic that is quite important, I think, for the sector in general, is the estimation of extreme wind speeds, and I'm talking also in the past, in the long term. So we found quite interesting this new Cape Shear variable. Also for forecast. So my question is similar. Is there does it exist as similar variable in ERA 5, combining Cape and Shear? Okay. Yeah, I know. Okay. Okay, thank you.
Yeah, I mean, if I could just comment more generally on the data store, I think, because obviously we try and produce some products, but it's almost impossible for us, well, it is impossible for us to sort of provide every product that you could possibly want. But up to now, the only way that, in a sense, the user could make the Taylor product would be to download gigabytes and gigabytes of data. The idea of this climate data store is to provide something in between, where you're, in a sense, working on our systems and can get the data on our systems, post-process whatever you want out of it. And so you're not having to sort of pre-download all the data in order to get what you want. So the vision is certainly to make it massively easier to produce the sorts of things you're wanting.
Not the individual.
Well, yes, or you don't even need to sort of download all the data to your system. You can sort of create whatever you want, effectively a cloud system.
Okay, I understand.
Whatever you're doing, you just give it back to the community. So it's, you know, it doesn't belong to you, but you can. I know it's maybe as a private company it's not so good, but
Yeah.
you know,
No,
this
but
is
I
public
think
data. So
yeah, I think that's a good point, because I think especially in the wind energy sector we all have the same problems. So the better we can share these kind of issues, the better for all of us. Okay, thank you.
More comments or questions?
We obtain the data from the web, the GRIP API, and we are finding some problems when we download the data. The main thing is that the efficiency is not really good. We lose a lot of time getting the data, and I would like to ask if you are planning any kind of improvement for the GRIP API. And another question, you said in the presentation that when you go to Bologna in the next 2 years, the GRIP API will be removed, and you said that it will be replaced by e-codes. EEC codes. Could you explain how is it going to work in this kind of method?
when you say GRIP API, you mean it's the decoder for the GRIP data? Is that what you mean? Okay, that you will have to move away from that. So we have EC code. EC code is software. You should be able to download it directly from our website. I'm looking at Daniel because he might know more than me. And you have to use that one. So GRIP API will just disappear. So the quickest you move to EC codes, the better it is. So there is all the documentation on the website. If you are patient, if you leave me your email address, I will send you all the links to the right location. We are not doing any more development on GRIP API. GRIP API is dying. So all the development will be done on EC codes, our new software package for decoding data.
All right. So is the EC code already available?
Sure. It's been available for a couple of years already. Yeah. So we can definitely, we have a software support. So you can send email to the software support. They will be able to help you out if you are struggling. Otherwise, you have this colleague here, Daniel. He seems to be very knowledgeable. But our software support person is also very good. So we use a ticketing system. I don't know if you're familiar with Jira. And you can just post your questions, and then he will be back to you as soon as possible. But the software you can download the package directly. And remember to leave me your address, and I will send you all the links. Yep.
Thank you.
I am not representative of ECMWF, but the difference is you are talking about two things. One is the decoder and the manipulation of the things, that is GRIP API, EC codes. And the other problem is the availability of the information. I mean, the transfer, the speed, and so on and so on. And this is related with accessibility to the MARS, to the archive. So it's the two things that are different. Yeah. Yeah, but because probably they are retrieving directly from Mars or not? I am not sure. Yeah, we need to discuss afterwards.
I just wanted to say that for us, in our case, we use Mars, the Mars archive, and we have problems when we try to retrieve a big chunk of data from there. It's very slow or not very reliable. So this is an issue that we have. And then, as we are talking about these kind of things, then the same with you, maybe.
And you are doing the most you can do. You know how to do the retrieval in the most efficient way.
Okay, the technical details, I don't have them. This is a question of... but
we retrieve the data for other purposes. Usually in Ireland, it's for computing boundary conditions, and now we are using EBS, so we are retrieving massive amounts of data to process these EBS boundary conditions. And we are working on some efficiency on Mars, so we are in contact with Carsten and users for and also Dominique about how to do this in a more efficient way. So probably we are doing some tests on different ways from Ireland community that probably is going to benefit afterwards the rest of the people outside of this. Yeah, but the main idea of this is, as they have mentioned, is to avoid to download huge amount of data from Mars and compute the things there. Now, easy codes allow you to do interpolations and some simple manipulations with the data there in the computers of ECMWF, but don't allow you to do special things devoted to you. In the future, the idea is to move to the other paradigm. Is you don't need to access to the data, you can compute things there and retrieve only the set. So this is going to improve this accessibility to the data in almost real time or not real time.
Concerning the change from grep API to easy codes is not difficult because most of the functions and capabilities are within easy codes. So without doing anything special, it could work. No, you don't think so? Yeah. Yeah.
My name is Beatriz Navascues from IMET, and my question is about the content of the CDS. Right now, there are multi-model products concerning seasonal forecast, and there will be also multi-model climate change projections, isn't it? But this is not a case of reanalysis. How, or is it?
Reanalysis, yes.
Yeah, reanalysis, it is, do you plan to increase the number of reanalysis, the available reanalysis within the CDS?
Yes, absolutely. ERA 5 will be on the CDS.
Yes, but only one world reanalysis. Do you? My question is about the concept of multimodal seasonal forecast, multimodal climate change projections. But in the case of reanalysis, you will have only one version of reanalysis. You will not have access to other existing reanalysis in the world. I refer, for example, to MIRA 2 from NASA or Ensemble or GMA, or because there are also uncertainty in the reanalysis.
No.
This is the idea I would like to explain. Just to tell you, the reanalysis is not the truth. We would like, but it is not the truth.
No. I guess a partial answer, a very partial answer to your question is that ERA 5 itself has a bit of an ensemble within it. But
Yes, of course.
As you're saying, I agree.
Yes.
I'm not aware of any plans to make that multi-model. Thinking about it, I agree with you. There's no obvious logical distinction between why it's done for seasonal forecast, but not the reanalyses. So, I mean, certainly, ask back with the Copernicus team. I mean, what we do under Copernicus is, I guess in a sense, less in ECMWF's gift than some other things, because it's all very much the negotiation with the European Commission directly as part of the follow-on delegation agreement. But so I don't believe there's any plans in the direction you say, but I will check. No, that's an interesting point.
But you are aware that your Yes, I know it. The idea is just to have an estimation of uncertainty concerning some variables that perhaps are more, is not geopotential or either surface pressure, but other variables that perhaps would be differently
more uncertain.
Surface barrier,
I guess if I'm allowed to ask a question, we've talked a lot about sort of access to data and some of the challenges around that. I mean, I'm just interested in whether AEMET or the other representatives here, just sort of quality of forecasts and just are there particular angles that worry people? Or, we're obviously striving to make them better on all fronts, but I mean, are there particular aspects, either at different time ranges or particular variables or particular geographies that people are worried about? Or, is there something that you sense we're not worrying about enough that we ought to be worrying about more?
Yes, in IMET, our forecasters in general are quite worried about these situations, these events with a high orographic enhancement, in which, as it is normal, a global model has some problems. And it is one of the reasons that in the short range, sometimes they prefer to use a deterministic model because of the resolution, especially. Because it's the double. In my opinion, regarding the use of EPS, they are using EPS more and more than in the past, EFI, the overseeding thresholds, but still in the short range, as we have a country with quite complex orography, with 2 seas and 3,000 meters mountains, especially with thunderstorms and fog, the horizontal resolution of the EPS is a problem. So, two problems. The horizontal resolution with local phenomena, and as an example, the events with orographic enhancement.
Yeah. Okay, and that's obviously sort of the balance when I was showing the sort of the experimentation we're doing on the ensemble. That's the trade-off. What I'd like is a big ensemble at high resolution. And the 2025 vision is the 5-kilometre ensemble, which hopefully tackles both of these issues.
It will be better.
It's what route we take to get there. I guess, in terms of the short-range phenomena, the fog or the short-range orographic enhancement, how much should that be a priority for us versus, would your limited area models, in a sense, downscale in that information?
Well, in the operational environment, if we have more models, it's better. Yeah. So obviously we use the harmony around model, but if we have the ECMWF solving better this local phenomena, like flat, or it's better for us because we have two outputs.
Okay. About this. Okay. The target from Harmony Around, from Hillam community, is to work on the first 2 days for forecast. So our model now is running on 2.5 kilometer resolution, and we plan to increase the resolution 1.3 or more, and also move to EPS on short range. And one of the problems really is ECMWF, and I want to mention is they try to create something that is very homogeneous from the starting point to the seasonal forecast. And the problem is how to deal for the forecasters with this inhomogeneity between our limited area model and this global model on other resolution. And the other problem is really we are working in the same framework, really. So now we are running here operationally cycle 40. Our next cycle will be cycle 43. So we are 2-3 cycles behind, almost ECMWF. So the main problem is how to homogenize all this information for the forecasters. This is the key point from my point of view.
I have a concerning your last increase in resolutions due to this cubic grid. I'm a bit puzzled because you keep the spectral resolution, but you increase the grid space resolution, and then you look at the output from the European Centre and the fields are quite smooth. In general, they don't look like 9-kilometer resolutions to me. And then you have the effective resolution of the model, which could be. So, can you comment on that?
I'm not sure. I mean, I certainly agree with you that, yeah, any numerical model, the effective resolution is definitely not what the nominal resolution is. So, I mean, that's one reason I think, you know, limited area models at sort of whether it's a 1 or 2.5 kilometer resolution for a long time, a long time in the future, will be doing something that the global models can't. You know, even with our vision of a 5 kilometer ensemble, which we want to do, you know, genuinely think that will provide you with better services, there will absolutely be a role for the higher resolution models to downscale beyond that, because any of the models, smooth relative to their grid scale. In terms of the change to the cubic grid, you're right, effectively, because the model has its spectral resolution for some of what it does, and then its physical resolution for where it does the physics and the like. And traditionally, I guess, if we're increasing resolution, we would have increased both of those together. So we'd have gone to sort of more points for the physics, but also upped the spectral resolution. Whereas on that resolution change, we found we could get most of the benefit by upping the physical resolution, so it's the cubic grid rather than linear, but not actually changing the number of spectral bands. So I guess that was more just a sort of a cost-effective way to get the most we could out of a given amount of computer resource. But I absolutely agree with your sentiment that all models are smooth. Yeah, even if they did have information right at their grid scale, I wouldn't believe it anyway. The numerical schemes just can't handle it. I'm not sure I've really answered your question.
I would like to ask a question, but it's not about data or products. It's a little. Well, I would like to ask two questions. One is Brexit. Sorry. What could you comment on the possible implications of Brexit for the ECMWF?
Okay. Well.
This is one. And the other question is, what part of ECMWF is Copernicus? What part of ECMWF is at the moment Copernicus?
Okay, I'll try that. So on Brexit, speaking as a UK citizen, I apologise. I have no idea what we were thinking. In terms of ECMWF, so I mean, obviously, in the most direct sense, we're set up as an intergovernmental organisation. It's not an EU organisation. That's completely robust against leaving the EU. There's lots of members of ECMWF that aren't members of the EU. So the existence of ECMWF and its headquarters and the rights of international staff, whether from EU countries or non-EU countries, to work in the UK are all completely unaffected by Brexit. The places where there's a potential effect of Brexit, probably more than they're going to come up with, but I don't think we're clear what the rights of families, as distinct from people that work at ECMWF, what the rights of families, children are. There's a funding line issue potentially I mean, as an intergovernmental organisation, we believe we're still completely eligible for EU funding, but whether a reality or a perception, whether there's a challenge there, I think there's probably just a perception issue for staff. Even having made the statement that any EU citizen, like a non-EU citizen from a member state, has a right to work in the UK, whether it's just off-putting as a place to want to live, just after the UK sends that message. On a more positive note, actually, we've done quite a lot of looking at recruitment statistics and application statistics, post-Brexit decision compared to before, and you can't actually see anything disturbing yet. Admittedly, it's on quite a short sample with quite noisy statistics, but there isn't evidence any evidence at the moment I could point out that says our ability to attract top talent from around Europe has gone down. In terms of Copernicus, so effectively, obviously, we that is a contract we run specifically on behalf of the European Commission. Again, we believe there will still be support for ECMWF to continue to run that, but the negotiations over the second delegation agreement are going on at the moment. In terms of what's done in it, there's a lot of work there, because most of the Copernicus money goes into ECMWF and out again in procuring services from other countries around Europe. In terms of the actual ECMWF scientific work that's supported by Copernicus, it's most of the reanalysis work and a little bit of the seasonal work is funded through Copernicus. Did that answer your question? Ask again the bits that it didn't answer.
The question was very short. Roughly, I would like to have an estimate of what part of work at ECMWF or computing resources and so on is 10%, 20%, 50%, just to have a rough idea of...
So on computer resources, Copernicus is about 2 million euros out of about 15 million. So 2 over 15 of the computer. In terms of staff, there's a big error bar on this estimate, but of the scientists, as distinct from the people doing procurement and the like, I guess there's probably 20 or 30, that sort of number, out of 330. So 10%. So I think the short answer, 10-20% of the overall organisation.
People like myself, I work 30% of my time on Copernicus and the rest on ECMWF.
90% for the rest.
And so it's basically a couple of days a week for Copernicus, 1 day and a half for Copernicus and the rest for ECMWF. So we have quite a number of people that are on part of their time on Copernicus, and because there are lots of activity that are actually, ECMWF and Copernicus is the same sort of, and my specific case is training, for instance, it goes across ECMWF and Copernicus, and many others are in the same position.
So I don't think we can get away from the fact that there's uncertain times. Nobody knows when the negotiations will end. Nobody knows what the UK government's position is, including the UK government, it appears. I'm not going to say that. But I believe we're as well placed as we can be, given the uncertainties. But we can't deny this. It's unhelpful uncertainty.
So I had another question regarding the seasonal forecast, System 4 or System 5. We're not quite updated. Is it already publicly available yet?
Yes, so System 5 became the operational seasonal forecast back in November.
System 5. Yes. So it's in a monthly update, and is it free, or is it a payment service?
Yes, if through the Copernicus route, the seasonal forecasts are available free. If there was extra data in the ECMWF catalogue, I mean, I don't know, I'm not sure exactly what's in the Copernicus offering, but yeah, that would be your first port of call, I'd have thought.
So the Copernicus offering is a number of seasonal forecasting systems. So one of them is SIS5. We call it SIS5. So you may see label SIS5. Yeah.
Okay.
But it's part of a bigger picture of model, seasonal forecasting model for Meteo France and other locations.
Okay. Thank you.
Just a very specific question about seasonal forecasting in Copernicus. I was being told that the 5 system which was planned for the Copernicus seasonal system would be ready around spring this year. April was the month which was suggested to me. But for the moment, only 3 models are offered through the Copernicus channel or the Copernicus web. Can you give me some estimate of the delivery of the 2 other systems, or the German and the Italian?
Yeah, I think no would be the only safe answer. But if you give us your details, we can check. Because absolutely, the work is going on, working with the Germans and Italians, looking at the quality of the system, integrating them into it. As far as I know, it's all going fine. But the bit of information I wouldn't have is to confidently say on what date it's going to become available. But if you make sure we've got your details, we can find out an answer.
The point is mainly, internal checking.
As far as I know, just checking, I guess, both the scientific quality and sort of operational robustness of the delivery routes. So, when it's envisaged, that will be complete, such that as a user you have access to it. I don't know, but we'll find out.
Yes, an additional question: the interruption of the EuroSIP products will be immediate after the addition of the two system.
I don't think
still missing in Copernicus, or there will be some transition period, or
I think yes, there will be some overlap period. Nobody's going to expect all the users to sort of turn over overnight, but I think there would be encouragement to already be looking to move to the existing 3-model Copernicus service, because that's definitely the future. I know that the providers to Eurosep, UK Met Office and Météo France, are keen to stop doing that, because the data feeds they're having to provide aren't exactly the same as the feeds that are needed for Copernicus, so it's making 2 lots of work for the providers at the moment. So the vision is definitely to get rid of Eurosep as quickly as reasonably possible, but I think the next steering group meeting, I expect to agree on a realistic date and to circulate that to the users.
Actually, quite interesting for me. Is it the communication that you get for it? Is not clear, or this why you're asking this? I'm guessing that information on when the things are going to be stopped and what is available, it's done through the normal communication channels. But to me, it seems as though maybe these communication channels are not clear enough. In terms of, defining dates when the services will be stopped, etc. Or I'm just trying to find out whether there is something we can improve on the communication side, that's all.
Well, I receive mainly this information, speaking with colleagues.
Okay.
I don't know of other more formal communication
Yes.
channels, either speaking with the responsible person at ECMWF, ANCA, for example, told me a few months ago that in March or April would be the 5 models ready for operations or for distribution, and we are now in May and haven't seen.
Sure, sure.
Yeah.
It's just because
I don't know if there are more formal communication channels.
Yeah, but you know, even if we have formal communication channel, they should be reach out to everybody.
Yeah.
So obviously, we may need to feed back to our comms unit in the Copernicus department. That the communication doesn't reach out enough.
Yeah.
Or it's not clear enough.
Yeah. When you, as a user, you click in the Copernicus page and you go there, you see 3 models, and I don't see any information saying that the missing 2 models will arrive in 1 month or in 1 week or in 3 months. I mean, for me, that would be ideal.
Yeah. So I will feed that back to the comms unit in Copernicus.
And also, not only for the 2 missing European models, but for the plans to enhance the system with the American and I think the Japanese one,
these are the
which is the status of the conversations with them and which are the barriers. Or it would be very good to have this information in the web page itself.
Sure. Okay. That's noted. Yeah.
My question would be related to EFAS. I would like to know if there are any plans to develop a model with a higher resolution or with a smaller pixel, or there are plans to introduce features like dams or pumping stations or whatever. I know it would need to retrieve information about dams and so on, but I only want to know if it's something in the road.
Honestly, I'm not absolute. I know that they have just developed some flash flood indicators, which was quite recent. Do you know anything about the dams? Because, you know, the Spanish is also part of EFAS. Yeah.
Last week I was in a conference in Vienna, and there is a presentation from EFAS responsible on this conference, and you can find the information about the new upgrades on there. It's the only information I know. So, but there are some plans of upgrading the resolution of the EFAS product.
There are indeed. So.
Yeah.
Anything else?
Coming back to Copernicus. Well, I have a concern, and I would like to tell you, and it refers to the continuity of Copernicus. The present program will end at the end of 2020, and we are still preparing within the climate change service this multimodal seasonal forecast system. And well, this is the main, the most vulnerable product for me, because as users, we know right now that this service will start officially by June this year, more or less, having 4 models or five models. But at the end of 2020, after that, what will happen? because we can try to develop downstream services based on this, but in order to develop new downstream services, we need some time. And it's 2018 right now.
I mean, you're right, the existing delegation agreement runs to 2020, so in a sense, I'm not in a position to give any 100% guarantees beyond 2020, because it depends on the results of negotiations with the European Commission. Having said that, without giving any guarantees, I'm very confident that they've been pleased with the sort of build-up of C3S, that the sort of multimodal seasonal is seen as an important aspect of it. I mean, in a sense, it was designed to be a sort of building on and a bigger and better Eurosip. So, I don't care how I word this, but I would be surprised and disappointed were there not something very similar to the multimodal seasonal existing through the 2020s. I can't give a 100% guarantee, but I would be optimistic that we want to do it and that the Commission are receptive to this is providing a useful service. So so it's absolutely part of our case that we're very actively making to the Commission about what should happen after 2020.
So is there anything else?
We have another discussion this afternoon, so but I want to discuss briefly or to chat about scalability efforts on ECMWF. I know that it's a key target for ECMWF and also it's a key target for our community in Ireland. The main problem that we have now is ECMWF is opening several lines, OOPS, Scope, Atlas, Panther and so on and so on and so on. And all these things are impacting us as in the framework of the developing the models and also in the framework of availability of new things and new improvements on the scalability of the models itself. So it's a discussion how we can participate and how can we have, that I have these coordination meetings with Deborah and with Claude about how to tackle these problems. But nowadays we are affected by all these kind of things, although we are participating with Escape and other projects. So it's something that I want to mention, that it's good to have this scalability program. It's good to have all these things, but time to time it's affecting to the limited area model community in the sense that it's creating some noise.
I recognise the issue and very happy to discuss further. Yes.
Okay, maybe it's time to close the session. Is anything urgent issue you want to raise? Otherwise, from the delegation, is there any question or remark?
I think I really just wanted to say thank you for all your review.
Yeah. Yes, I think so. Not many, but yes, at least Hannah is there. Any question from the delegations? No? No? Okay. Thank you.
Thank you for listening to all the people outside. It was, hopefully it was useful.
Okay, and thank you everybody for coming and for this active discussion. So we hope for the next time we can organize something similar. Okay.
I just have a quick question. Can I ask maybe somebody from IMED, could you just provide me a list with all the names of the various data user here, because I didn't catch all the names, and and the companies and so on and so forth. Yeah? So if you could provide your, just at least the name of the company, and if you want the contact detail, if you could then give it to me, that would be useful. Yeah.